So waves, question 4, D and E. So some students investigate the properties of waves generated in the figure above. Student A says the waves move water from one end of the tank to the other. Student B said that's wrong, only the waves move, not the water. Suggest what the students could do to decide which of them is correct. So, what they can do to decide which of them is correct. So, we have 2 marks. 1, 2. Okay, so this is an interesting thing here. So the one student says water moves from one end. The waves move water from one tank to the other. And this one says only the waves move and not the water. So they need to find something to find out whether the water moves from one end of the tank to the other. Okay, so they could measure the depth of the water at either end. Okay, before the wave and then after the wave. So here they're saying this one, both of them are saying right before the wave we have that, before the wave travels. This one's saying that this must happen eventually. Okay, so this is after the wave's moving all the water that way, whereas this one's saying actually this is what happens. The waves move, not the water just moves up and down. So what could you do to identify which one's right? Now the easiest way to do that would be to place a float. Place a float in the water before the wave passes, or before the wave moves. Okay, so if you've got a float in the water before the wave moves, then that will tell you either if the float moves that way, then all the water moving, but we're suggesting that it's only going to go up and down. So we know that student B is correct on this. The water is going to go up and down. So the float should move only up and down as wave passes, proving student B correct. Okay, so how would we make sure that we show that student B is correct? Question E. Another student uses a ripple tank where all the water is the same depth. It will stay in the same place or only bob up and down. She measures the wavelength of each wave as 0.34 meters. The period of each wave is 0.42 seconds. Calculate the speed of the wave. Use the correct equation from the physics sheet. Give the unit. There's lots of stuff here. Give your answer to 3 simple figures. Okay, so there's an awful lot to do. So physics equation sheet, we've got to calculate the speed of the wave, period of the wave is that, the wavelength is that. Okay, so and it's worth 5 marks. So quite a few marks for this question. So because it's worth 5 marks, because there's a lot to do, I'm probably just going to separate my answer area straight into 3. So 1, 2, 3. That'll give me some space now to work. I'm going to go back to every sheet. Again, I can't work out where to put it. It's not in the way. Can't see it there. Right. What do I know? So my equation, first of all, calculate the speed of the wave. Okay, speed of the wave. Well, speed of the wave, I lose my equation sheet and I find that wave speed equals frequency times wavelength. Okay, so I'll find that in my equation sheet. What values do I know? So values from this, I know the wavelength, which is lambda. So lambda is equal to 0.34 meters. The period, which is capital T, T is equal to 0.42 seconds, and that's all I've got. Okay, so that's all I've got. Well, I've got wavelength, that's that, great. I need to find out, how do I find frequency? Well, frequency, if I check my equation sheet, frequency is related to time period. And I know that t, the time period, so period, equals 1 divided by frequency. Okay, so I've got that. Well, if I rewrite that in terms of just the symbols, 1 divided by f. Okay, so that will give me f. So let's find that. So I've got my values. I'm going to do enter my values first. So I've got 0.42 seconds. So 0.42 is equal to 1 divided by f. I'm going to times both sides by f. So 0.42 f is equal to 1. Divide both sides by 0.42. 1 divided by 0.42 gives me a frequency. Frequency is 1 divided by 0.42 equals 2.38 hertz. Then go back over here, so wave speed is v equals frequency times wavelength. Well, I've now got f, so v is equal to f, which is 2.38 times by wavelength, which was 0.34. I'm going to make sure I use the original, I know that's the number I've written, but I'm going to use the value from my calculator, because it's quite a lot longer. 34 gives me a total of 0.8095. Okay, is that. So last thing I'm going to do, so I've got a value. Last thing I'm going to do is just check, I need to do the unit. So it's 0.8095 unit is speed, meters per second. I'm just going to go through and check, have I done everything I need to do, because there's lots. I've calculated wave speed, yes. Correct equations, yes. Give the unit, yes. Give my answer 3 significant figures. I haven't done that yet. So let me make sure I do that. 3SF would be 0.810 meters per second. So 3 SF. Okay. So quite a difficult equation. That's quite a difficult complex equation. I would probably go back through and check that all again. It's interesting. I'm looking here at the mark scheme, and they've got a slightly different answer. Let me just check what they got. So 1 divided by 0.42 is equal to 1 divided by 0.42 equals that. So they've got a rounding error on their answer. Okay, because they rounded that up to 0.238, whereas I left it as the original 0.23867, whatever it was, 243. Okay, but that's, hopefully that works. That shows you how to do that, how to work out that answer. I might well remember then as well to put it over here. It's not the end of the world if you don't. You may well have got the answer, which the marks will do as well, 0.8093 SF. Okay, that's absolutely fine. That's because you've rounded over here. Even if you didn't know how to do this equation, this question, you'd still get a mark if you just put the units down, 1 mark. It's always worth giving it a go to see if you can scrape as many marks as you possibly can. Okay, hope that's helpful.